Just imagine, you're staring into the black sky thinking the universe is silent and still. Then suddenly, a beam of light cuts through the void, from a point millions of light years away. Now picture this, it's not a star, not a supernova, but something eerily familiar. A glow like it came from a city. A city that shouldn't be there. This isn't science fiction, it's what the James Webb Space Telescope may have actually seen. Yes, the JWST picked up beams of light, artificial in appearance, seemingly radiating from what looks like an urban zone deep in space. And that's not even the most shocking part. This light, astonishingly, seems to originate from a specific location millions of light years away. When this discovery was announced, it reignited serious discussions among scientists about the possible existence of extraterrestrial civilizations. And just when the world was trying to make sense of this strange light, the telescope turned its gaze toward Proxima Centauri b, the closest known exoplanet to Earth. What it saw there sent another wave of shock through the scientific world, bright, unnatural bursts of light shining through the darkness. Could this be artificial illumination like a city at night? Could someone, or something, be living there? For years, the possibility of alien life has captured both scientific minds and the public imagination. Countless theories, endless speculation, and millions of people asking one simple question: are we alone? Any hint of an answer is enough to electrify the world. But what JWST captured this time went beyond hints. It was direct, visible evidence of something unusual, something that could suggest intelligent life on another planet. Light patterns so specific and precise that they resembled artificial illumination. The kind of light you'd expect from a living, breathing city, not just random starlight. And here's where it gets even more incredible. These mysterious light emissions weren't coming from just any planet. They were seen on Proxima Centauri b, a rocky exoplanet located just 4 light years away from our solar system. Scientists have studied this planet for years due to its proximity and Earth-like qualities. But nothing had ever stood out like this before. It was the first time such precise beams were seen there. Some astronomers believe this could indicate an alien metropolis, perhaps operating with technology so advanced that we can barely even comprehend it. The implications of this finding sent a wave of excitement through the scientific community. For them, this wasn't just a theory, it was the breakthrough they had long been waiting for. For decades, researchers have hoped to find evidence of intelligent life. Now, thanks to the incredible sensitivity of the James Webb Space Telescope, we might be standing at the edge of a historic moment. This instrument has opened a window into a reality we couldn't observe before, revealing lights that might have been shining there for years, just waiting for our technology to evolve enough to finally see them. David Kipping, a renowned astronomer from Columbia University, was among the experts who spoke out about this strange discovery. He described Proxima Centauri b as uniquely complex compared to other rocky exoplanets. Typically, such planets absorb light from their stars and re-radiate that energy as infrared heat. But in this case, the behavior was completely different. The detected lights appeared artificial, structured, and rhythmically pulsing. That's not how natural planets reflect light. This suggested some kind of anomaly, and the kind that might hint at technology. This behavior was made visible because of JWST's advanced capability to detect infrared wavelengths. Unlike other telescopes that are limited by faint light and deep space distance, the Webb telescope is uniquely equipped to notice even the weakest signals in complete darkness. It excels at seeing what other instruments can't. And because it was able to track the planet during its night cycle, it gave scientists a full picture, possibly revealing lights that only come alive after the planet's sun goes down. Here's how it works. JWST can pick up narrow-frequency light, narrower than what normal stars emit. This is crucial. Artificial lights from a city would likely emit within that kind of narrow range. And that's exactly what the telescope observed. This level of precision raises real possibilities. Unlike general starlight that appears scattered and broad, this was focused, intentional, and consistent over time. It's what makes researchers pause and say, something strange is happening here. Proxima Centauri b also has a very dynamic relationship with its star, Proxima Centauri. The interaction between them has a huge impact on the planet's environment. Just like Earth, the planet experiences cycles of day and night. But the differences between the two halves of the planet are far more extreme. As it rotates, one side faces intense heat from the star, while the opposite side falls into bitter cold. If the planet has an atmosphere, which scientists still hope to confirm, then the temperature difference between night and day would be dramatic, even more so than anything we see on Earth. This massive temperature fluctuation is crucial to understanding whether the planet is truly habitable. Astronomers believe that if Proxima Centauri b does have an atmosphere, then its climate could still stabilize across time. And JWST plays a huge role in that analysis. It doesn't just see light, it also detects thermal radiation, which helps scientists understand what kind of gases, weather, and air pressure might exist on the planet. That's how we learn whether a planet is burning, frozen, or possibly somewhere in between. Somewhere livable. Have you ever imagined seeing city lights from another world? Not just a fantasy, but something real, something captured through a telescope floating a million miles away from Earth. Well, that imagination may be crossing into reality. The James Webb Space Telescope has just picked up something no one expected. An astonishing burst of light, almost like it's beaming out of an alien metropolis. These aren't just flashes. They seem organized, patterned, and bright, originating from a region millions of light years away. Could this be a cosmic coincidence, or the first true evidence that we are not alone? Buckle up, because what you're about to hear might just be the start of the most important discovery in human history. The telescope had recently directed its gaze toward one of the most intriguing candidates for alien life, Proxima Centauri b, the exoplanet closest to our solar system. What it found wasn't just the usual stellar noise or background radiation. No, this time it recorded brilliant bursts of light far too structured to be random. These radiant emissions have reignited global interest in the idea that intelligent life may exist beyond Earth. Scientists are cautious, but their curiosity is off the charts. Could these glowing signals be signs of a developed alien civilization using technology we don't yet understand? The idea of life beyond Earth has always fascinated both scientists and ordinary people alike. For decades, we've searched for even the smallest hint, a strange chemical in an atmosphere, an unusual radio signal, a mysterious anomaly in telescope images. But now, for the first time, we have something that feels less like a whisper and more like a shout. The James Webb Space Telescope has possibly given us a direct glimpse at light emissions that resemble those produced by cities here on Earth. It's a discovery that's stirring the scientific community, opening up possibilities that once seemed reserved for science fiction. This extraordinary find was made while the telescope was scanning the universe, methodically observing light and infrared emissions from distant worlds. Among them was Proxima Centauri b, sitting a mere 4.2 light-years away. That's incredibly close on a cosmic scale. When Webb zoomed in, it saw something shocking: structured lights that mirror what we see in our own cities when viewed from space. That's right, the kind of illumination that, here on Earth, only intelligent civilizations produce. It was a sight so bizarre and yet so compelling that even the engineers and astronomers at NASA were stunned. David Kipping, a leading astronomer at Columbia University, noted that Proxima Centauri b doesn't behave like typical rocky planets. Most rocky planets absorb light from their star and re-emit that energy as heat in the form of infrared radiation. But this one? It breaks the rules. There's a complexity to how it interacts with its star that has baffled experts. These bright emissions hint at an artificial source, something capable of maintaining a steady glow on the planet's night side. It's a clue that something intelligent might be harnessing or producing light in a way we've never seen before. The key to all this lies in the Webb telescope's incredible infrared sensitivity. Unlike traditional telescopes that struggle to detect faint signals in the deep void of space, Webb can catch the smallest glimmer in the darkness. This ability allowed it to detect the alleged city-like lights on Proxima Centauri b. What's more, it can isolate artificial light frequencies that are extremely narrow, far more focused than the broad light spectrums emitted by stars. This makes it uniquely capable of confirming whether those mysterious lights are natural phenomena or something else entirely, perhaps artificial. Proxima Centauri b is a planet with a very active relationship with its parent star, Proxima Centauri. As it orbits, it undergoes dramatic shifts between day and night, much like Earth. However, the temperature extremes on this planet are far more intense. If it has an atmosphere, the difference in heat between the day side and the night side would be enormous. One side might be blisteringly hot, while the other is absolutely freezing. This contrast is crucial to understand, as it could offer insights into whether the planet's environment could support life, or even complex systems like cities. The James Webb Space Telescope can actually track these thermal shifts by detecting the planet's infrared emissions, helping scientists build a picture of its atmospheric conditions. Even more fascinating is how Webb's orbit around Earth lines up with Proxima Centauri b's 11.2-day orbital cycle. This synchronization allows researchers to observe the planet's temperature changes and lighting conditions with remarkable accuracy. If there's truly an atmosphere there, the next big step is to analyze its composition. Scientists will look for life-friendly chemicals like oxygen, water vapor, and methane. Finding those could be the smoking gun in the search for alien life. However, even though Webb is incredibly advanced, it does have limitations. While it's brilliant at spotting water vapor, carbon dioxide, and methane, it struggles to detect free oxygen, one of the most crucial signs of life. But there's a workaround. Webb can look for ozone instead. Ozone, which is made from oxygen, serves as a powerful indicator of a planet's atmospheric health. And if ozone is found along with water and methane, it could very well suggest that some kind of biological processes are occurring. Maybe not humans, but something alive. Even though Webb is our most powerful space telescope yet, it can't scan every exoplanet. Its observational window is narrow, focused mainly on the closest candidates. That's why scientists are already looking ahead to ground-based giants like the Extremely Large Telescope, or ELT, which is expected to begin operations in 2027. The ELT will give us a much closer look at distant planetary atmospheres, delivering more detailed and precise data. Where Webb leaves off, ELT will pick up, acting almost like a detective zooming in on the most suspicious clues left behind by alien worlds. There's a lot of excitement building around these next-generation telescopes. They're being designed to solve one of the biggest challenges in exoplanet exploration, overcoming the blinding glare of nearby stars. Think of it like this: trying to see a faint planet next to a star is like trying to spot a firefly next to a stadium floodlight. It's almost impossible. But new technology like starlight blocking devices are changing the game. These innovations work like putting your hand up to block the sun so you can see what's in front of you, simple in concept but deeply complex in execution. One of the most promising tools is something called a coronagraph. It fits inside a telescope and works by precisely shaping and filtering light waves to block out the star's overwhelming brightness while letting the dim planet light pass through. By using this method, astronomers can finally isolate the light bouncing off distant planets and start analyzing what it's made of. It's a delicate process requiring microscopic precision, but the potential payoff is massive. With a coronagraph, we could finally read the chemical signatures of alien worlds, and maybe spot a planet with signs of life. Another fascinating technique involves a structure called a star shade. Imagine a giant, flower-shaped shield floating in space, perfectly aligned thousands of kilometers in front of a telescope. The star shade would block the light from a star before it ever reaches the telescope lens, letting only the light from orbiting planets come through. This method could be revolutionary, especially for viewing planets in the habitable zone, the sweet spot where liquid water could exist. But the technology isn't easy. Aligning two spacecraft that far apart to a precision of fractions of a millimeter is incredibly challenging. There are other hurdles too. Space equipment must be lightweight, energy efficient, and built to survive harsh conditions for years or even decades. But despite these difficulties, the rewards could be transformative. If we can successfully observe exoplanet atmospheres in such detail, we might find what scientists call biosignatures. These are chemical patterns, like oxygen, methane, and water, in ratios that strongly suggest biological activity. It wouldn't just be a theory anymore. It would be the first real sign that life has taken root somewhere other than Earth. And we're not stopping there. Scientists are working on ways to go beyond just detecting atmospheres. The dream is to directly image the surfaces of distant exoplanets. With advanced adaptive optics, future telescopes will correct for atmospheric distortions and produce crystal-clear images from across the galaxy. Combine this clarity with starlight blocking tech and we might be able to do what was once unthinkable: map the surfaces of alien planets, analyze their climates, and look for continents, oceans, and perhaps even structures. This would mark a whole new era in planetary science. As we push forward into the unknown, the development of next-gen space telescopes marks one of humanity's most ambitious efforts ever. Every innovation brings us closer to answering a question that has haunted us for centuries: are we alone? With each new telescope, each burst of data, we peel back another layer of the universe's grand mystery. The James Webb Space Telescope has already changed the game. But what comes next could completely reshape our understanding of reality. We're now moving faster than ever in the quest for extraterrestrial life. Scientists around the world are diving deep into the mysteries of distant exoplanets. The discoveries being made are not just interesting, they are groundbreaking. The James Webb Space Telescope is leading the way into a future filled with cosmic revelation. The data it's gathering is helping astronomers unlock new insights about the composition, structure, and potential habitability of worlds far beyond our reach. And with every new discovery, we inch closer to answering the ultimate question: are we truly alone in the universe? Proxima Centauri may be just one planet, but it represents a doorway, a possible gateway to one of the most profound revelations in human history. If those lights are real, if that atmosphere is stable, and if the biosignatures are confirmed, then we may have already made first contact without even realizing it. And that, on Mole, would be the beginning of a new chapter in the story of humanity. When NASA launched the James Webb Space Telescope, the world expected revolutionary discoveries, and now, yet another incredible milestone has arrived. In a distant, young star system still forming its planets, the James Webb Telescope has detected something stunning: the unmistakable signature of frozen water. Not just water vapor or traces of hydrogen and oxygen. This is solid, icy water found in a region where planets are just beginning to form. This detection, coming from over 450 light-years away in the Chameleon I cloud complex, marks a major first in the history of space science. It's proof that the essential ingredient for life, water, is present in the raw building blocks of new worlds. To understand why this is such a big deal, we have to consider how planetary systems form. In the early stages, dust and gas swirl around a newborn star in a structure called a protoplanetary disk. Over time, these particles stick together, forming pebbles, rocks, and eventually full-sized planets. But for life as we know it to have any chance of existing, water must be available at some point in the process. Until now, astronomers could only speculate whether ice, specifically frozen water, was present in these disks early enough to be incorporated into the emerging planets. Now, thanks to Webb's unmatched sensitivity, we finally have hard evidence that ice does, in fact, exist in the early phase of planet formation. The telescope focused its powerful instruments on a specific young system known as IRAS 15398-3359, a relatively small protostar located in a dense cloud of gas and dust. Even though this object is only about 100,000 years old, a cosmic newborn, it already has a developing disk and an outflow of material that indicates active formation. When Webb observed this system, its near-infrared spectrometer picked up unique absorption lines in the light spectrum, lines that precisely match the molecular signature of water ice. This means frozen water is present on the grains of dust floating in the disk. These are the very materials that will go on to create planets, moons, and perhaps even comets in this young system. What makes this observation even more exciting is that it supports one of the most important theories in planetary science: that Earth-like worlds may acquire their water not just from internal geological processes or late-arriving comets, but right from the very first ingredients in the disk. If frozen water is present so early, then the chances of forming watery worlds around other stars, possibly even habitable planets, are dramatically higher than previously assumed. And since this system is very similar to what our own solar system might have looked like billions of years ago, it offers a direct window into how Earth may have gotten its water. But Webb didn't just detect frozen water. It also picked up several other types of ices, including frozen carbon dioxide, methane, and even more complex organic molecules. These frozen chemicals are the raw ingredients of life, the basic components that, under the right conditions, can form amino acids, proteins, and eventually living cells. That means this single young star system contains nearly everything needed to start a biological chain reaction, provided the right environment forms around it. In a way, Webb didn't just observe ice, it may have captured a snapshot of life's potential in its earliest, most fragile form. Of course, finding these ices wasn't easy. The Chameleon I cloud complex is incredibly dense and cold, which makes it ideal for preserving frozen materials but also extremely challenging to observe. Earlier telescopes like Spitzer and Hubble could barely penetrate the thick dust, but Webb's powerful infrared sensors were designed exactly for this type of work. It can peer deep into these dark regions and detect faint heat